Hi, I'm going to continue with the same time series problem that we had. It's a very small problem, so we'll be able to demonstrate several calculations. The time series is, we have previous or past time periods going back 5 years. 1, 2, 3, 4, 5. And the time series is the actual y values are 450, 495, 518, 563, and 584. To do a 2-period moving average, 2-period moving average, we will take the oldest 2 data values, that would be the 450 and the 495, add them up and divide by 2. And whatever the answer is, we're going to use that as the forecast, and this column right here, we're going to create forecasts for a 2-period moving average. So the 450 plus the 495 give us an average of 472.5. And notice how I'm using that or putting that across from the 3rd period. So we're saying that for period 3 now, the actual was 518 and the forecast using this method of 2-period moving average will be 472.5. Then we will drop the oldest data value out and we will pick a new one. So now we're working with 495 and 518, adding them up, divide by 2, and we will use that as the forecast for the 4th period. And that answer is 506.5. And then again we drop the oldest data value out of among those two, and we'll pick up a new one. So now it's between it's 518 and 563. Add them up, divide by 2, and we get 540.5. And if we drop the oldest one out again, we'll get the 563 and 584, add them up and divide by 2, and our estimate or our forecast for the next period will be 573.5. Now you might ask, why are we going back and creating estimates of past periods? We do that so that we can judge the accuracy or the amount of error included in this 2-period moving average model. For that, we can calculate several measures of forecast accuracy. One that we can do is MAD. MAD is mean absolute deviation. Mean implies average, absolute means absolute value, and deviation is distance or error that the model has made, that the forecast is from the actual. So these are actuals. So 518 and error, we can calculate error then. Error is always the actual minus the forecast. So 518 minus 472.5 is 45.5. 563 minus 506.5 is 56.5, and 584 minus 540.5 is 43.5. Now, as it happens in this case, all of our error terms are positive, meaning our forecasts were always lower than our actual values. But sometimes our errors might be negative values, meaning that the forecast might have overestimated. In such a case, if you just add up this error column, the positive and the negative error terms might cancel each other out, and you might end up with something very close to 0, and you might erroneously conclude that you have a very good model, that it didn't make too much mistakes, whereas it's because of the positive and negatives canceling each other out. So for that reason, when we do MAD computation, we use absolute error. So we take absolute value of the error terms. So taking absolute value, of course, in this case, it doesn't make any difference as to what the absolute value doesn't change. Absolute value is always how many units on a number line, how many units is a number away from 0. So if this is 0, this is 1, 2, 3, -1, -2, -3. 3 is positive 3, it's 3 units away from 0, and -3 is 3 units away from 0. So absolute value of a number is always, it implies how many units is it away from 0. So in this case, all of our absolute error terms are as listed here. To compute, and those are our deviations, deviation of the forecast from the actual. So we need to average them. If you sum this up, summation of that column is 145.5. And then if you average that 145.5 divided by 3, gives you MAD, mean absolute deviation, which is 48.5. So MAD equals 48.5. So you can compute other measures of forecast accuracy as well. Another one is called MSE, mean squared error. So MSE. So it's your error term, which we computed. And let me put the errors down. These are absolute errors. But the error terms for this problem are 45.5, 56.5, and 43.5. So if you take these error terms and square them, then you have 2070.25, 3192.25, and 1892.25. Then if you add them up and divide by 123, you get MSE, which will be 2384.92. 2384.92. Also, you can calculate MAPE. MAPE is mean absolute percent error, and it's preferable over the others because and it's preferable because it's a percentage of error that the model has made. And MAPE is always percentage of error as far as the error factor relative to the actual value. So to compute MAPE, you take absolute error and you divide it by actual value. And you do that for every data value that you have. So here, absolute percent error would be, you will take your error, which is 45.5, and you divide it by 518, and you get 9%, so 0.09. Or for this one, you will get your error, which is 56.5, and you divide it by the actual, which was 563, and the percent error would be 0.1. And then the next one is 0.07. And remember that these are, you take the absolute error and you divide it by the actual. So these are always going to be positive numbers because it's an absolute value computed as a percentage. Then what you do is you take the mean of them or average them. So the average of all of these is going to yield MAPE equals the average of these three would be 9%. The summation of these is 26%, and when you divide it by 3, you get almost 9%. So that's how you compute different measures of forecast accuracy. There's another one probably that you can do, which is the tracking signal, but this at least gets you started in terms of thinking along those lines. Now another thing is that this is just one forecasting method that we have computed. This is a 2-period moving average. You could create a 3-period moving average column of forecasts, and then once you generate those forecasts, then you can go ahead and compute MAD, MSE, and MAPE for that also. And when you do, then you can compare the two models, the two methods, and see which creates for you better forecasts. So generally, of course, you want the MAD or the MSE or the MAPE, all of them, to be lower in number because they're reporting average error. And since you want error to be low, you would want those numbers to be low when you're comparing two models. So you will go with the model that has the forecasting method that has the least error. Thank you. I hope you found this helpful.